Hey guys, welcome to another Swift deep dive. In this deep dive, we're going to be learning all about Swift classes, what they are, what they can do, and how to create them. Now, classes, like structures, are again a way of defining a blueprint. They're a way for us to be able to plan out properties and methods, and eventually, when we run our app, be able to initialize our class into an actual object. So in this lesson, I'm going to talk about how to create an object from a class. But in addition, I also want to talk about some of the core concepts of object-oriented programming, namely inheritance, subclasses, superclasses, what it means to override a method, and what it means to call a method from a superclass. So let's create a separate project in Xcode to show these concepts in action. I want you to go to File, New, and choose a new project. Now, when you see the wizard, I want you to choose macOS and select the command line tool. Now, the reason for this is we're not actually creating an entire app, but we are creating a project which can have multiple Swift files associated in the same project. Our project name is going to be called Classes Demo, and then you can go ahead and click Next and save it anywhere you like. So this is what you should end up with, and notice how we have a main.swift file that already gets created for us, and inside all we have is just a print statement. So I want you to delete everything that's currently inside your main.swift, and you'll notice that when we run our project this time, what will happen is it will look inside the main.swift file and run all the lines of code in here as if it were a playground. So if I wrote print hello, well then that is what will be run and printed into my debug console when my program runs. So we can expand this and we can collapse the right hand pane. And in fact, I'm also going to collapse this left hand pane so we have a full length debug console. So now it looks pretty similar to what we have when we create a playground. But in this case, I can actually create multiple files inside the same project, my class's demo project. So how do we write the code for our class? Defining a class is very similar to defining a struct. We have the class keyword, and then we have the name of the class, which is capitalized from the start, and then we have a set of curly braces inside of which we can define the implementation of the class. Let's create a new Swift file for a class in our project. So here I'm going to right click and I'm going to create a new file in that folder, which is going to be a new Swift file, and then hit next. And now I'm going to name my file the name of the class that I'm going to create, which is going to be called enemy. So let's imagine that we were building a simple game where we have to create enemy characters for our game. So the first thing I'm going to do is I'm going to delete all the code in here. We are going to create our code entirely from scratch. In this enemy.swift file, I'm going to create my enemy class. To create my class, I'm going to use the class keyword, and then I provide the name of my class, which is going to be called enemy. And it is convention that when you create a class, that the name of the file matches exactly the name of your class. Now I'm going to open a set of curly braces to define this enemy class, what it can do, and its properties and its methods. For the enemy characters in my game, they might have a number of attributes or properties, right? Things like maybe they would have a health stat. Let's say that they start out with 100 health. And they might also have an attack strength. So this is how hard they hit. Now these are the properties of my enemy class. But I can also describe behaviors that the enemies can perform. So I would do that by creating a function. Let's say that each of my enemy characters can move. So I could have a move function. And when this move function is triggered, all that happens is that the enemy characters walk forwards. Now we can also define a attack function. And when the enemies attack, what should happen is maybe they would land a hit and it will do some damage depending on the attack strength of this enemy character. So I'm going to use string interpolation to insert the attack strength value in here. So, for example, a default enemy character with an attack strength of 10, when it attacks, it's going to land a hit and does 10 damage. Now that we've defined our blueprint that defines an enemy character, it's time to go into our main.storyboard and we can initialize our enemy class here and create an object from that class. So to initialize a class, all we do is write the name of the class and then a set of parentheses. So in our main.swift, I'm going to create a new enemy. Let's say it's a little skeleton. And I'm going to initialize it as a new enemy object. So the name of the class and then a set of parentheses. So now that I've got this enemy object, which is a skeleton, I can tap into its properties. So for example, I could print the skeleton.health property. And if I run my app by clicking the play button, you'll see that the skeleton gets created on line 2, and on line 3 I'm printing its health, which turns out to be 100. And that of course comes from the default health property for everything that's created from the enemy class. Now, in addition to using the properties, I can also get my skeleton to do something. So I can write skeleton.move or skeleton.attack. So now if I run my code, you can see that the health is printed as 100. The skeleton now walks forwards, it lands a hit and does 10 damage. Just by creating this enemy class, I can now create lots and lots of enemies. I could create more skeletons. So skeleton 2 is going to be created again from the enemy class. And then maybe we could have a skeleton 3. And instead of having to create each one of them with a health stat and attack strength, define its behaviors, I've now used that template or that blueprint, the enemy class, to create 3 entire skeleton objects, which each can move, can attack, have all these properties. So as you can imagine, it's a lot easier to simply replicate and airdrop in all of these different enemies without having to define each of them from scratch. But in the last module, we saw how to use structs or structures, and we could do pretty much the same thing with them, right? But that's not where it ends. The magic of classes really lies within a special capability that they have, which is the ability to inherit from a superclass. So what do I mean by the superclass? And what does it mean to inherit from a superclass? Well, the key to understanding this is that we can have a relationship between classes. Think of the superclass as a parent. It knows how to do certain things and has certain properties and methods. However, what if we want to take its existing capabilities and build on top of it? Well, yeah, we could do this by adding more code to our existing class. But there's also another way. We can create a subclass and add our additional functionality there. Think of the subclass as the child of the superclass. The superclass has taught the subclass everything it knows how to do, for example, reading and swimming, and the subclass can now grow and develop its own capabilities, like playing with the iPhone, getting addicted to YouTube, or live streaming on Twitch. In other words, the subclass has access to all the properties and methods of the superclass. That's what we mean by inheritance. Now, let's see inheritance in action in our Xcode project. So let's say that I want to have these generic sort of simple enemies like skeletons. I don't know why skeletons always get a bad rep. They always seem to be the most easy to destroy enemies in any game that I've played. But let's say that we wanted to have a more powerful enemy. And we wanted to leverage the code that we've created in our enemy class, but we wanted to make it do more and be more specialized. Let's say that in my classes demo, I create a new file, again a Swift file, and I name this file Dragon. So I want to create a Dragon class in this file. So I do exactly the same thing as before, but this time I'm going to use the class code snippet that Xcode Autosuggest gives me, and I'm going to hit enter once I select it. Now this is the default way that we would create a class. Whereas before we created a class that was just a simple standalone class, in this case, I'm going to use the ability of classes to inherit from other classes. Firstly, I'm going to give this class a name, which is going to be my dragon class. And dragons are also an enemy. So they're going to inherit from the enemy class. So that means when I create a dragon from the dragon class, I don't actually have to redefine these properties or these methods. It already has inherited all of those properties and methods. And I can show you by simply going into my main.swift, and I'm going to delete all of this code here, and this time I'm going to create a dragon. So the dragon is going to be created from the dragon class. And now with my dragon class being completely empty, other than the inheritance from the enemy class, I'm going to use my dragon object, and I'm going to get it to move, and I'm going to get it to attack. So now if I go ahead and delete all of this code and simply go ahead and press run, you can see that when this line 6 runs, the dragon walks forwards, and it also lands a hit when the attack method runs. So without having to lift a finger essentially in our dragon class, we've already managed to inherit all the capabilities in the enemy class just by inheriting it, like so. Now that's not where it ends though. The whole reason that I created this dragon class is for it to be able to do something different. So let's create a property that is unique to our dragon class. So maybe it has a wingspan, and let's set it to a default value of 2 meters. So it's a medium-sized dragon. But when I create my dragon object, I could change that. So I could say dragon dot wingspan, and let's set it to 5. Let's make it a giant dragon. So this wingspan property, of course, does not exist in our default sort of enemy class. I can't say skeleton dot wingspan. That doesn't make any sense. Skeletons don't have wings. So that is a custom property that only exists inside the dragon class. But of course, the dragon class also has access to all the properties that the enemy class has because it's inheriting from it. So for example, it has the health property, it has the attack strength property. So let's set the attack strength property to a bit higher than your average enemy. Let's make it 15 instead of 10. But in this case, I'm creating a new dragon from the dragon class, and I'm tapping into a property from the superclass, so the class that we're inheriting from. Now, I also want my dragon class to be able to do something that the default enemy class can't do. Now, it seems to me like from all the movies I've watched, dragons always seem to be able to talk. So let's give our dragon the capability of speech by adding a method called talk. And this method is going to take a input called speech, and that's going to be a string data type. And then all that it's going to do is just print the words. It says whatever the speech happened to be. So I'm just going to insert that speech input in here. And now we've got a dragon that talks. So back in my main.swift, I'm going to say dragon.talk. And the speech that it's going to give is, my teeth are swords, my claws are spears, my wings are a hurricane. So now we've got a dragon that talks, that moves, that attacks. And if I run my code as it is, you can see that my dragon is talking, it's walking for some reason, and it's landing a hit, doing a 15-point damage. So you can see we've now got this dragon object created from the dragon class, which can do everything that the enemy can do, but it can do a lot more. So there's some custom things that only the dragon can do that a bog standard enemy can't. But if you look at our code, when the dragon moves, it probably shouldn't walk. I think it should probably fly instead of walk, right? So in addition to defining custom properties and methods, we can also tap into the methods that are available to us from the superclass, so the class that we're inheriting from, and we can override it. So if we tap into the move method, you can see that this override keyword goes in front of our normal function declaration. And this means now that when we trigger the move method, we can say it does something completely different. In my case, I think that when a dragon moves, instead of walking, it probably should fly forwards. So now if I go back to my main.swift without changing any of this code, I run my code, you can see now when my dragon moves, it flies forwards instead of walking forwards. And I've managed to achieve that by overriding this method that I got from my superclass and providing a custom implementation. So doing something completely different from the move method that the dragon inherited. Now, sometimes, however, you actually want the behavior of the method from the superclass. So in our case of our dragon, what if I want it to land a hit, do some damage, but also to maybe be able to spit some fire in addition? Well, in that case, I can do this. I can override the attack method from my superclass, and I can do something customized to the dragon class, namely maybe dragons should be able to spit fire, and it does 10 damage. But this is not all that I want it to do. I want it to perform the method that came from the superclass, the enemy class, which I'm inheriting from, but then do some custom stuff as well. So I want both the functionality of the attack method from the superclass as well as some functionality that I've added on as custom. So to achieve this, what I do is I use the super keyword, which refers to the enemy class, which I'm inheriting from, and then I write .attack. So now I'm triggering the attack method from my superclass, which will print land a hit does X amount of damage, and then I want to spitfire and do an extra 10 damage. So now if I go back to my main.swift and I run my code, when dragon.attack gets triggered, my dragon will first land a hit does 15 damage, which comes from super.attack, and then it's going to spitfire and do another 10 damage, which comes from my custom additional implementation of the attack method. So this really is the superpower of classes. You can see that by inheriting from the enemy class, I saved myself a lot of work and a lot of repetition. When we create functions, we know that they help us reduce the amount of repeated code by packaging a whole bunch of instructions inside the same package. Now, when we create classes and inherit from other classes, we're again saving ourselves from creating repeated bits of code, and instead we are just layering functionality upon a superclass. So in fact, without this capability of inheritance that comes from classes, we wouldn't have been able to build any of the apps that we have created so far. If you go to Help and Developer Documentation, you can see how inheritance is used amongst the components that are part of Apple's UI kit. And that includes almost everything we've shown on screen, like UI labels, UI sliders, UI image views, everything with a UI in front of it, basically. So for example, when we create a button, we're actually creating a UI button. So if you search for a UI button and click on it, you can see that this is a UI button class, and it allows you to respond to user interactions. But this class actually inherits from the UI control class. So if we click on UI control, we get taken to this class's documentation, and you can see that this is the base class for all of the controls, which convey a specific action or intention in response to user interactions. So we're inheriting some of these capabilities when we use a UI button. Now, a UI control itself then inherits from a UI view, which is an object that manages the content for a rectangular area on the screen. And then a UI view itself inherits from UI responder, and UI responder inherits from NSObject. So what does that mean? Why is it structured like that? Well, let's think about it in reverse. Apple's most basic class is the NSObject. This is the simplest and most generic component, and it's how Apple started out. The NS, in fact, stands for Next Step, which was the company that Steve Jobs started when he got kicked out of Apple initially. Now, the UI responder can do everything an NSObject can do, but it has its own additional capabilities. The UI view, in turn, builds on top of the capabilities of the UI responder, and the UI control builds on top of that again. At each level, more code and more capabilities are added. So the components become less generic and more specialized until finally we get a UI button that the user can press. So now that we've chased it all the way up the tree, we can see how it would take so much longer if we had to create everything from scratch and create all of our view controllers from scratch, all of our UI labels from scratch, rather than simply just inheriting and using the capabilities that Apple has already created within our UI kit. And this is all possible because of how classes work and how they're able to inherit from other classes. So in the next lesson, we're going to take a look at the difference between structs and classes and when we would use each. So for all of that and more, I'll see you there.